Hello friends. So we have a question on geometric progression and arithmetic progression. In the question we have been given three terms and it is told that in the A part that these three terms are in geometric progression. There is slight correction in this. The first term in this question is natural log of x. The second term is p times natural log of x and the third term is 1 by 3 natural log of x. So this p ln x natural log of x is 1 term. Now it is given in the question that the series is geometric, that these three terms are in geometric progression. When I am saying this, that these three terms are in geometric progression, it means if I multiply this by an r and then again this by another r, I will get the next term. So I can say p natural log of x divided by natural log of x must be equals to r, and this must also be equals to 1 by 3 natural log of x divided by p natural log of x. Correct? Now equating these two terms, we will get is p, since in both terms we have natural log of x, we can cancel this. We get is p square equals to 1 by 3. So p is equals to plus minus 1 by root 3. So these are the values of p. And if we see closely, the p is nothing but the common ratio. We call this term common ratio r. So p is equals to plus minus 1 by root 3, which is also equals to r. Now in the second part, we have to show that the series is convergent. Any geometric progression is convergent or converges only when the modulus of r is less than 1. So let us try to identify what is the modulus in our case. In our case, the modulus is plus minus modulus of 1 by root 3, which is 1 by root 3, and this is less than 1. Hence we can say the series will be convergent. Now let us move on to the third part. In the third part, it is given that consider p as greater than 0. So we had two values. Now we will consider p as 1 by root 3, which is also equals to r. And s infinity, that is the sum of these infinite terms of this geometric progression, is given as 3 plus root 3. Now the formula of s infinity is first term divided by 1 minus common ratio. So here our first term is natural log of x, 1 minus the common ratio is 1 by root 3. Equating this equals to the sum given, that 3 plus root 3. So we have an equation to solve. This is natural log of x equals to root 3 minus 1 divided by root 3 multiplied by 3 plus root 3. We can multiply this. This is 3 root 3 plus 3 minus 3 minus root 3 divided by root 3. Simple calculations. 3 root 3 minus 3 is 2 root 3 divided by root 3. That means this is 2. So what we are getting is natural log of x equals to 2, which means x is equals to e raised to the power 2. So our solution is x is equals to e raised to the power 2. So we have solved first, second and third. Now consider the case where the series is arithmetic with common difference d. Now in the b part, it is given that the series natural log of x, p times natural log of x and 1 by root 3 natural log of x, that is 1 by 3, sorry. 1 by 3 natural log of x. So we are given that these three terms now are in arithmetic progression. Now, in the case of arithmetic progression, what we generally do is that there is the common difference. That is, if we subtract the second term from the first term and then third term from the second term, the difference will always be equal. That means p natural log of x minus natural log of x must be equals to 1 by 3 natural log of x minus p natural log of x. So we can again remove natural log of x, and then p minus 1 equals to 1 by 3 minus 1, which is minus 2 by 3. So p equals to this is p minus 1 by 3 minus, sorry, this is, there is some correction here. The calculation needs to be checked. This is p minus 1 equals to 1 by 3 minus p. So this is 2p 1 by 3 plus 1. So this is 4 by 3. What we get is 2p equals to 4 by 3 or p equals to 2 by 3. So we have found the value of p, which is 2 by 3. Now in this second part, write down d in the form of k natural log of x. So we have to write down the p in the form of k natural log of x, in the form of natural log of x. So what is p? We know that the common difference d is p natural log of x minus natural log of x. So we get p minus 1 into natural log of x. Now, equating this p minus 1 into natural log of x equals to d. Now, do we know the d? The d, and now we know p, the value of p, so we can write d as natural log of x into 2 by 3 minus 1. So we get is minus 1 by 3 natural log of x. So we get a relation between the d and natural log of x. So we have written d in the form of natural log of x. This k times natural log of x. So if we compare, the value of k will be minus 3. So this is our solution for the second part. Now in the third part, what we have to do is the sum of the first n terms of the series is natural log of 1 by x cube. So it is given that the sum of n terms is natural log of 1 by x cube. The sum of the first n terms is natural log of 1 by x cube. We also know the natural log of the sum of n terms is nothing but n by 2, 2 times first term plus n minus 1 multiplied by d. So let us try to put the values. N by 2, the first term is natural log of x. Our series, the first term as we see is natural log of x. So this will be 2 times natural log of x plus n minus 1. We have already identified d in terms of natural log of x. So this is minus 1 by 3 natural log of x. And we are given that these two terms are equal. So using these two terms, we have unknown x as well as n. We have to identify the value of n. So let us try to see if we are able to solve it for n. So this is n by 2, 2 natural log of x minus n minus 1 by 3 natural log of x equals to natural log of, this can be written as natural log of x to the power minus 3. Now this minus 3 can be taken here. This can be the minus 3 natural log of x. So minus 3 natural log of x. Now we can remove this. what we get is n by 2, 2 minus n minus 1 by 3 equals to minus 3. So if we multiply it, if we open this is n minus n into n minus 1 by 6 equals to minus 3. This is 6n minus n square plus n equals to minus 8. So n square minus 7n minus 18 equals to 0. So this is n square minus 9n plus 2n minus 18 equals to 0. Taking n common, n minus 1 plus 2 n minus 9 equals to 0. So we get is n plus 2 n minus 9 equals to 0. So either n is minus 2 or 9. Now n cannot be minus 2 because n is a natural number. This is the sum of the first n terms, which cannot be a negative term. So the only possible value for n is 9. So this is the solution of our third part. So we have been able to solve all the part 1, 2 and 3. For more such questions, do visit our website www.iitnacademy.com and register for